For more complete testing of GPS receivers, we need to test using signals that include real-world impairments, such as multipath. Multipath signals are GPS signals that have bounced off objects and are received by the GPS receiver with power offsets, delay, and Doppler shifts compared with the line-of-sight satellite signals. In this video, we will demonstrate how to create scenarios with multipath impairments using the Agilent N7609B Signal Studio for Global Navigation Satellite System software with option RFP for scenario generation. Here is the equipment setup used for this demonstration. The N7609B Signal Studio software runs inside the N5106A PXB baseband generator and channel emulator to create the GPS baseband signal in the PXB. This digital baseband signal is then sent over an LVDS digital bus to the N5182A MXG signal generator, where it is upconverted to the GPS RF frequency and sent to the GPS receiver, a U-Blox 5H evaluation kit. The GPS receiver sends its information via a USB interface to the U-Blox U-Center evaluation software for display. Let's look at how we create scenarios with multipath. When a custom scenario file is created in the N7609B Signal Studio software, it contains only the line-of-sight satellite signals. We can use the scenario editor to add the multipath signals. From the Scenario Generator tab, we go to Generation Mode and select Edit. We will select the dynamic scenario file that we created in a previous video as our starting point. This dynamic scenario is for a GPS receiver that is moving in a path along a circle with a radius of 1 kilometer. The Scenario Graphics tab provides a graphical view of the channels in this scenario over time. Here we can see the individual channels and their associated satellite numbers, which are color-coded. In this example, we see that satellite number 7 is red and in channel 1, satellite number 8 is green and in channel 2, and so forth. There are a total of 10 line-of-sight satellites. We will now add some multipath signals to this scenario. Back on the Scenario Generator tab, we go to Edit mode and select Create Multipath. We select channel 1 as the source and a new channel, channel 11, as the destination. We will add a delay of 0.5 chips and a Doppler shift of 0.1 Hertz. We then select Apply to add this multipath to the scenario. Next, we add more multipath signals by copying channel 2 to channel 12, and then channel 3 to channel 13. For demonstration purposes, we won't apply a power offset, so the multipath signals will be at the same power level as the line-of-sight satellite signals. Once we are done with all of the changes, we click on Save Scenario to save the modified scenario file under a new name. On the Scenario Graphics page, we can see the results of our edits. There are now 13 channels total. Channels 11, 12, and 13 are copies of channels 1, 2, and 3, as we can see by the color of the satellites. We can now go to the GPS Settings tab, select the circle scenario with multipath, and select Play. On the GPS receiver software, we see the same 10 satellites as we did in the previous demo, but now we can see that the satellites with multipath, numbers 7, 8, and 11, are varying in power. This can be clearly seen in the satellite level versus time display. The power levels fluctuate above or below the power of the other satellites as the line of sight and the multipath signals either add or subtract from each other depending on the phase of the signals. From the deviation map display, we can see that even with the multipath, the GPS receiver is able to correctly track the trajectory along the circular path with a 1 kilometer radius. The 3D and 2D accuracy values are less than 5 meters. As a further experiment, from the Settings tab, we can turn off most of the line-of-sight satellites, leaving only the 3 multipath signals plus 1 other satellite to enable a location fix. We can see from the U-Center software that the accuracy of the location fix has degraded, and we can also see from the deviation map that the GPS receiver is reporting locations that are now deviating from the correct trajectory along the 1 kilometer circle. In conclusion, GPS receiver verification requires a GPS simulator capable of recreating real-life scenarios, including impairments such as multipath. In this video, we've demonstrated how the N7609B Signal Studio software can be used to create these custom scenarios with impairments. For more information, please contact your local Agilent Technologies representative or go to the web at www